Okay, students, I am waiting for you all to join. It is almost 1:10, so I will wait for a couple of minutes before we begin the session. Good morning, Shoham Shen. Yes, please tell the others to come, Shoham. Welcome, Asmita. Welcome, Dia. Good afternoon. Welcome, Ankit. হ্যাঁ বল আমি তো 12:30 পরেই মার্কস দিয়েছি বাবা। হুম না, আমি 11:30 পরেই কিন্তু মার্কস দিয়েছি। যারা আমি 11:30 পরেই আপলোড করেছি, মার্কস সাবমিট করেছি। আমি 11:32-তে সাবমিট করেছি। আমি 11:30 বলছি, 12:30 পরেই আমি সাবমিট করেছি। সেটা সেটা আইএমসিআরপিতেও দেখাবে, সেটা আইএমসিআরপিতেও দেখাবে, তাই দেখাচ্ছে, আমাদেরকেও তাই দেখায়। দ্যাট ইজ নট অ্যান ইস্যু, বাট দোজ হু হ্যাভ not received the attendance, perhaps the only reason is they have submitted after 12:30. হয়তো 1 সেকেন্ডের ডিলের জন্য এটা হয়ে যেতে পারে। কিন্তু বেশি কিন্তু নেই আমার কাছে, অনেকেই তো এসছিস। হ্যাঁ, একজন দুজন হতে পারে, বাট বিকজ মোস্ট অফ ইউ আর প্রেজেন্ট, আমি দেখেছি। ঠিক আছে, আমি এখন ক্লাস নিচ্ছি, ঠিক আছে, পরে করিস, ঠিক আছে, ওকে। হুম। Okay, good afternoon to all of you. Today's class is a very, very important class that is on decision theory, which I would like all of you to participate in. I am only seeing 6 of you are there. Where are the rest? 50% of the students are there out of 12. 6 are there. Where are the rest? Okay, one more have joined. Please don't delay. Yes, Abhi, good afternoon. Ask the others to come in, please. Okay, let me start. Decision theory deals with taking decisions. When do we take decisions? A simple question. I don't want you all to answer this, but it's a very simple question. When do we take decisions? When there are alternatives. If there are no alternatives, there is no point in taking decision. If you are asked to do something, you have to do it. You have to do it. There is no question of taking decision, whether I will or I will not. But if the scope is given, you may or may not do it, then you can take decision. So decision theory is based on taking decisions under alternatives, alternative courses of actions. Okay, now I think we have got the full strength of the class. Okay. Now, I believe that all of you have got the study material, the one page written format that I circulated to all of you regarding decision theory. So this I hope everybody is having with you. So I will refer to this constantly because it is a numerical paper and some amount of conceptual understanding is required. So at the very beginning, I have mentioned I've mentioned five terms that needs to be understood. Number one is what is decision? Decision means choosing an alternative. If there are no alternatives, there are no decisions. In your operational research classes, you had found in linear programming, in transportation modeling, assignment theory, you have found that there was no alternative. One way was coming out from the algorithm. After the algorithm was solved, only one way was coming out. One transportation route was coming out, or one optimization of x of z was coming out of linear programming. So that was the decision. There was no alternative. But here there are plenty of alternatives. When there are plenty of alternatives and you are not very easily successful in finding out which alternative is the best, then comes the picture of decision theory. Then you have to take decisions. Next is alternatives. What does alternatives means? Alternatives means the available courses of actions under which under a state of nature. Available courses of action under a state of nature. Alternatives are under our control. Which alternatives I will choose is under our control. But alternatives are courses of actions under a state of nature. Now, what is a state of nature? This is the third point. State of nature refers to the external environment. The external environment, that is the market environment or your internal business environment or whatever. The external environment which influences your return after taking a decision is known as the state of nature. And it is called, what does it mean? Again, I'm telling you, if suppose a state of nature Si is existing, Si or S2 or S3, whatever is existing in the market, under which I don't have any control, and I am taking a j number of action, that can be H3, A4 or A5, whichever action I take, course of action, whatever return I am going to get That is called payoff. Now, all these three things summarized together: state of nature, courses of action, and payoff. These three things summarized together in one matrix is called payoff matrix. Everything summarized together in one matrix form is called payoff matrix. And an example is given in a payoff matrix. It is called a conditional payoff matrix. Have a look at your note. Please see an example I've given. In the columns, there are the alternatives A1, A2, A3, A4, and the rows it is S1, S2, S3. Those are states of nature. And in the box inside, they are the payoffs 5, 6, 2, 4, -1, 10, -3, 6, and so on. So these are conditional payoffs. So this matrix is called conditional payoff matrix. Till here, is it clear? I want 2 or 3 yes responses or no, whatever. If it is not clear, I will again explain. Is it clear till now? Karishma says yes. 2 or 3 responses. Abhi says yes. State of nature. Okay, Ankit is saying state of nature once more. All right. State of nature is the external environment. See, when I am taking a decision, when I am choosing an alternative, I do not know what kind of market environment will be there externally. Say, for example, there are three kinds of possibilities of a market. A recession can be there, stability can be there, growth can be there. There can be three types of market conditions. Growth means boom. Boom type of market can be there, stable market can be there, recession market can be there. So, which market will be there tomorrow or next year when my decision is going to be implemented? I do not know. And I don't have any control over that. So, that state of the external environment is called state of nature. Okay, so we move on. Now, there are two components of decision theory. There are two cases under which decision theory is applicable. We need to take decisions through the mechanisms of decision theory. There are two cases. The first case is risk, and the second case is uncertainty. First case is risk, and the second case is uncertainty. That has been mentioned here. What is risk? Risk is a case where we know the probabilities of the state of natures. Whatever the states of nature are, we know the probabilities of them occurring. Maybe you want to go into the garments manufacturing business next year or next 5 years. So after 5 years, what is going to be the garments industry's condition? The probabilities you know. If you know, you are working under risk. If you don't know, you are working under uncertainty. So if probabilities are known to you, it is risk. If probabilities are not known to you, it is uncertainty. So it is basically a continuum. At one end, you have got certainty. In certainty, you don't need decision theory. At the other end, you have uncertainty. In middle, you have risk. If I draw a line, at one end, you have certainty where you don't need decision theory. In the middle, you have risk where you have got partial information about the market, that is the probabilistic information. At one end, you have got the uncertainty, where you have got no information about the market, not even the probabilities. So, is the difference between risk and uncertainty clear? Risk is the case where you know the probabilities of state of natures. Uncertainty is where you do not know the probabilities of the state of nature. Okay, fine. Now we move into risk. How do we calculate which alternative we should choose under risk? For that, we need to convert this conditional payoff matrix into an expected payoff matrix. The conditional payoff matrix needs to be converted into an expected payoff matrix. How do we do that? By multiplying the values with their corresponding probabilities. I've given an example towards the end. If you see closely towards the end, there were three states of nature. Alternatives were also three: 10, 30, 20, 5, 2, 10, 10, 20, 20. These were the payoffs. And the probabilities were given 0.3, 0.5, 0.2. Now, when you are converting this conditional payoff matrix to expected payoff matrix, what we do, I have written here, convert by multiplying the payoffs with the corresponding probabilities. So 10 into 0.3 gives you 3. 30 into 0.3 gives you 9. 20 into 0.3 gives you 6. 5 into 0.5 gives you 2.5. 2 into 0.5 gives you 1. 10 into 0.5 gives you 5. Accordingly, you are doing the calculations. Is the calculation part clear? The conversion from conditional payoff matrix to expected payoff matrix. Is the conversion clear? Just again, 2 or 3 yes or no's. Otherwise, I'll not understand whether you are understanding or not. Okay, fair enough. You said yes, sir. Okay, now see. Add up the columns. Okay, don't respond anymore now. Now focus. Add up the columns. Add up the columns. The first column, the first alternative's addition is 7.5. The second alternative's addition is 14. And the third alternative's addition is 15. What these values are? These values are expected monetary values. These are called expected monetary values, EMVs. And we choose that alternative which has got the maximum EMV. Amongst all these three alternatives, the maximum EMV is of 15. That corresponds to A3. So our decision is we choose A3. I will show you here. These were the three EMVs. Out of this was the largest. So we choose A3 as our alternative. Fine. Is this clear? Okay. Now, we move on to a critical concept. This concept I have not written it here. I'll just explain overbound. Please understand the concept very carefully. And if you have a pen and paper, please write it down. You need to write it down, I think. Have a pen and paper, please write it down. The concept is of EVPI. EVPI. Expected value of perfect information. expected value of perfect information. Now, I'm giving you an example. Suppose you have come up with this information that based on the probabilities, listen very carefully. This is slightly complicated concept. Listen very, very carefully, okay? You have come up with a calculation that under risk, under these probabilities known, you know that you expect 15 rupees profit if you choose A3. So you will obviously choose A3 because 15 is the highest. So you will get 15 rupees profit. So this is what I am telling you that you have already calculated. Now, suppose I am a third person who comes into your building, at your home, at your office, wherever, and tells you that I'm a consultant. I will do a market research and will let you know exactly which state of nature will exist. I will let you know exactly which state of nature will exist. Okay? But I'll not do it for free. Remember, I'll not do it for free. You have the probabilities. Let me show you the difference. You have the probabilities now. Based on the probabilities you have calculated. And what you have calculated is you will gain 15 rupees. Fine. I am telling you, I will give you the exact information, not the probabilities. Out of S1, S2, S3, which one will prevail? I will give you the exact information, but against a fee. What is that fee? 50 rupees. I will charge 50 rupees to do all my calculations plus my profit. Will you give me this chance? Will you pay me 50 rupees so that I can give you tomorrow early morning the information that which state of nature will exist? Will you give me 50 rupees? I want an answer. Yes, no, yes, no. I want to see how many says yes, how many says no. I am a consultant. I have come to you and I'm telling you I want 50 rupees. Give me 50 rupees. I will give you the exact information and then you can go for it. Others, I had two responses yet. I have only two responses. I want others to respond. All of you are saying yes randomly? Okay. Stop responding. This is where the actual concept of decision theory comes. I will calculate first whether 50 rupees is worth it. Okay, stop responding. Listen now. I will calculate first whether 50 rupees is worth it. Whether the information worth 50 rupees. See, very carefully. I have given you this offer and I have gone back home. Now you are calculating. If I tell you tomorrow that S1 will occur, you will go for A2, obviously, because A2 gives you the maximum profit. If I tell you S1 will occur, very carefully understand. If I tell you, I have not yet told you, I have not yet told you, if I tell you S1 will occur, you will go for A2. If I tell you S2 will occur, you will go for A3. because that gives you the highest profit. If I tell you S3 will occur, you will go for A2 or A3 because that gives you the highest profits, 2020. I'm referring to this part. But which one I have told you or which one I'm going to tell you, it is not yet decided. I have not told you anything and you haven't given the money yet. You will call me and tell me that whether you will give me the money or not. Now, if S1 occurs, then this 30 into the probability becomes 9. So, this 9, I hope it is visible, this 9 is your highest value against state of nature 1. If I tell you that state of nature 2 will prevail, corresponding probability, if you multiply with it, 5 is the highest value. And here 4 is the highest value. So, with my help, how much you are expecting? With my help, how much you are expecting? Without my help, how much you are expecting? 15 rupees. Without my help. But then I have come, I have told you, I will give you the correct information. Then you are calculating with my help how much you are expecting. So what you will do, you will add these three. 9 plus 5 plus 4. That is 18. This 18 you will add. This is the amount that you are expecting with my help. And without my help, 15. So what is the difference? Difference is of 3 rupees. Difference is of 3 rupees. Abhi says, for S3 there are 2 4s. Yes, you can take any one of them. Abhi says there are 2 4s here, one for here, one for here. You can take any one of them. I am only talking about the highest value per state of nature. You can take any one of them, doesn't matter. Okay, now there are 2 values here. One value is 18, which you are expecting to get 18 rupees with my help, and you are expecting to get 15 rupees without my help. So what is the difference? Difference is of 3 rupees. Only 3 rupees. So you will be, or if you are sane in mind, clear in mind, clear in concept, then you will say, you will tell me that I can give you up to 3 rupees, not more than that. Because if I give you more than 3 rupees, it is better that I will do my own calculations. Is it clear? Plain and simple. With my help, you are getting 100. Without my help, you are getting 50. So if I ask you to give me 200, will you give me 200? No. You will give me up to that amount, which is the difference, 150. With my help, 100. Without my help, 50. So up to this amount, this 50, is what you will give me. Okay. So what is EMV? EMV is exactly this amount, this difference. Expected, sorry, not EMV, EVPI. EVPI is expected value of perfect information. expected value. How much does the perfect information cost? Information also has a price. It also has a cost. You cannot give any cost for an information. You must calculate. It is like utility. You have studied in economics. This much utility you are getting and this much price you are paying. So if the utility is more than the price, you will pay. If the price is more than the utility, you will not pay. It's as simple as that. So here we will go for that. So I will ask, so you will tell me, I can give you, sir, 3 rupees only, up to 3 rupees if you can give me perfect information. More than that, I don't require your help. Because without your help only I am getting 15 rupees. And if I pay you 3 rupees, I will run loss. I would not even get 15 rupees. With your help, I am getting 18. If I give you 3 rupees, I'll get 15. But if I give more than 3 rupees, 4 rupees, I'll get 14. So I'll get less than what I am getting without your help. So this is the concept of EVPI. EVPI, so the formula, please write down the formula. EVPI is, all of you please write down the formula. EVPI is expected value with perfect information. EVPI full form is expected value of perfect information. Expected value of perfect information. There's a difference of and with. Expected value of perfect information is equal to expected value with perfect information minus maximum EMV. Expected value with perfect information minus maximum EMV. So what is expected value with perfect information? This 9 plus 5 plus 4. This is the expected value with perfect information. And what is the maximum EMV? This 15. So this 18 is expected value with perfect information minus maximum EMV gives you EVPI, that is 3 rupees. So you can afford to spend up to 3 rupees to get the perfect information. Is it clear? Now tell me, is it clear or not? Tell me, some of you. Please respond. Abhi says yes. Good. Read this portion in your decision theory book. In the book that you've got, I think there is a subject called optimization techniques. In that subject also you will get decision theory. So there also you will get EVPI. So please read this section very carefully. Okay. So most of you are saying yes. Fair enough. So this is risk. So today we will stop up till this much, because if I move on further, the space will run out. It's already about 40 minutes. So we will stop till here. Next day we will discuss about uncertainty. It's a very, very simple process, uncertainty. We will discuss about uncertainty next day. Okay? Any questions? Okay. Please give the exam. Please give the exam now. I'll I've given you the exam code. Did I give you the exam code? Abhi, did I give you the exam code? Yes, Abhi. Did I give you the exam code? Ankit, Asmita, anyone please respond? No, I have not given you the exam code. Okay, just hold on. Just hold on, I'll give you the exam code. This is your exam code. Okay, please give the exam. Okay, class, thank you very much. Thank you for participating.